today we talk about that correlation. We have already studied that LTI system and that convolution. Now today we talk about that correlation, which is another kind of operation which is look like convolution, but instead of folding we just sliding the sequence. So why this correlation is important? Why this? What is correlation and why it is required? So as you heard that the word correlation means the relations between the two signals. So suppose I have a signal, I have another signal. If I want to find out what is the similarity between the two signal, that is called correlation, which is called a mathematical operation which is very similar to the convolution. But it is not that a signal is convolved with other signal, it is a measurement of the similarity. So if I have a signal, two signal, when I say the correlation, I want to find out the measurement of similarity. So correlation is another signal which is derived from that two signal which indicate the similarity between the two signal. So there is a, if the signal, suppose one signal is my x of n and another signal is my y of n. When I say the similarity between the two signal, then it is called cross correlation. When I say the similarity between the itself, then it is called autocorrelation. So let us define it mathematically. So correlation. So Rxy, that Rxy is the measurement of the similarity between the two signal x and y. So I have a two digital signal, one is x of n, another one is y of n. Okay. I want to find out how much similar is y of n with x of n. So what I want to find out? I want to find out that how much similar is yn with x of n. So measurement of similarity. So how do we measurement the similarity? So similarity measurement will be indicated by Rxy. So similarity of y with x, Rxy. So how do I do that? So if you see that, suppose that, let us say forget about the signal, think that I told you what is the similarity between this object and this object. Or you can say that if I ask you what is the similarity between you and your friend, you may say, sir, my hairstyle and my friend hairstyle are same. My nose tip and my friend nose tip is same. May not be similar, but same. So how much similar? If I said it is hairstyle is similar, is it exactly similar or how much similar it is? So if I want to measure, then what I will do? One things will be there, I will superimpose will be another things, and if they are similar, they will be exactly match. So if I say mathematically I want to do it, so I have a signal x of n and I have a signal, another signal y of n. If let us say the sample 1 x of 0 is similar with y of 0. So if it is both are similar, how can I do that? I can take the product and sum all sample similarity. So that will be indicated that x of n is similar with y of n. So similarity index number 0. So L is equal to 0. Now you may say, suppose y of n is a large signal and x of n is a very small signal. So let the length of the x of n is m and length of the y of n is n. So m is less than n or m is greater than n, x of n is large, y of n is small. So now if I say only R0, then it may not be similar with at the initial position, it may be similar at here. Inside the signal there exists some portion where it is exactly similar. So how do you do that? So for that purpose, what should I do? Suppose I want to measure the similarity of xn in the signal yn. So, what I said that how similar is xn with yn. So, what I will do, I will make the xn is fixed and I slide the yn. So, what I will do, I left shift yn minus L. So, let us say this is one signal and this is another signal. So, what I will do, I will first calculate the R0, then I shifted this portion to this side and find out the correlation. So, I first calculate R0, then R1, then R2, then R3, then R4, then R5. So, I sliding this yn over this left side and find out the similarity. I can do the same thing, let this yn remain constant and I can switch that xn this side. So, this is right side shift. So, I can same things I can do with a x of n plus L yn. So, how do I find out the similarity? I have a two signal, there is a two signal. So, this signal is yn, this signal is xn. So, what I will do, first I put this yn with 0 0. So, L equal to 0. So, both signal are here. Now, either I shift yn this side or I can shift xn this side. So, when I shift yn this side, what is the operation? Left shift operation. So, I can say yn minus L while I am shifting this one. But while I am shifting this one means x of n plus L. So, I am shifting it this side, left side, and I am shifting this is right side. So, I can both way I can calculate the correlation of x with y, Rxy, correlation of x with y. Similarly, I can say correlation of y with x. So, I just replace the x by y and y by x. The equation is same. So, let us say this one I can compare with this one. So, if I compare this one and this one, both are shift is this side. I can compare. So, if I compare this one, so it can be proved that R of xyl is nothing but a minus R of yx minus L. Okay, so this is the relationship. But how do we calculate the correlation? The same, procedure is same, mathematical procedure is same. This is yn, this is xn, either I can shift this one or I can shift this one is this side. So, let us do an example. Suppose I have a signal yn and I have a signal xn and arrow indicate the 0th position. So, if I plot xn, so this is 0th position, the sample value is 1, then xn has an minus 1, 0, then again minus 2, it has value 1. Similarly, 0 it is 1 and 1 it is 2. So, this is x of n. Now, what is y of n? Y of n minus 1 I have a value 1, 0 I have a value 2, 1 I have a value 1, 2 I have a value minus 2. I will take eraser, this will be not here, this will be this side, minus 2. Here also this is not 2 plus 2, this is minus 2, this side. Okay. So, now what I do? I want to find out Rxy 0. So, 0th position, L equal to 0. What is the equation? My equation is n equal to minus infinity to infinity x of n multiplied by y of n minus L. So, I am shifting y signal with x signal. So I impose the y signal with x signal and shift it and find out that R0. So R0 is no shift, L equal to 0. So L equal to 0. So it is nothing but a minus infinity to infinity sum of the product of the sample and then sum. So now I can see I have a signal x of n which has a value, sample value minus 2, I have a value 1, and minus 1 I have a value 0. So I can say this, I can see that x of n minus 2, maximum minus 2 I can say. So I can say n equal to minus 2 to n equal to 2, or you can infinite also, because I am doing this because outside this the signal is 0. So I can easily say x of r x of y 0 means x of minus 2, then y of this is y of minus 2, because L equal to 0, plus x of minus 1, y of minus 1, plus x of 0, plus y of 0, plus x of 1 into y of 1, plus I can say x of 2 into y of 2. So x of minus 2 I have a value 1, y of minus 2 I have a value 0. So 1 into 0, plus x of minus 1 I have a value 0, y of minus 1 I have a value 1, plus x of 0 I have a value 2, x of 0 I have a value 1, x of 0 I have a value 1, y of 0 I have a value 2, 1 into 2, plus x of 1 I have a value, x of 1 I have a value minus 2, y of 1 I have a value 1, plus x of 2 I have a value 0 into y of 2 I have a value minus 2. So if I see all are 0, only this two term will be there. So it is 1 into 2 minus 2 into 1. So I can say it is 0. Similarly, I can calculate R x y 1, you can calculate R x y 1, you can calculate R x y 2, like that way. So you do it in your paper, pen and paper, and see whether it is matching or not. So those are the measurement of the similarity between the two signal. If it is x and y, it is called cross correlation. If I say R x with x slash the y signal is not there, find out the similarity R x with x, which is called autocorrelation. So when I say R x with x, so R x with x 0 is nothing but each of the samples will be multiplied and added up. So I can say which is nothing but x of n whole square, which is called energy of the signal. So if it is autocorrelation, then R x x 0 is nothing but the energy of the signal. Now you may say, why should I require this kind of autocorrelation, cross correlation? Why should I find out that? What is the use of correlation? The main purpose for correlation was to find out the similarity. So using that similarity, finding out what we can do. Suppose I give you a periodic signal, told you determine the period of the signal. So what is the periodic? If the two signal, if this signal, I have a signal, I have to determine the period of the signal. So what I can say, if the signal is periodic in nature, then the value of our autocorrelation value will be maximum at 0 and at a period. So that's why autocorrelation is used to find out the periodicity of a signal. Similarly, if you are reading about the radar signal analysis, suppose how a radar signal finding out a target. So, you know that a periodic signal is transmitted by a carrier. When it is reflected back, due to the Doppler effect, there will be a delay in periodic signal or phase change in the periodic signal. So, if the phase change, I can find out the similarity, and if there is a phase change, the similarity index will be changed. If it is exactly the same signal I receive, so I can find out that if I find out the correlation, it will be very high. If the similarity is changed, then I can say there is some shift is happened. So, that is why autocorrelation used for find out the similarity. Now, autocorrelation used in speech for find out the periodicity. So, now you can use this algorithm, or you can directly from this math, you can write down in C code or MATLAB code to find out the autocorrelation of a two sequence. Okay. Now, what are the correlation of a periodic signal? Let us say cross correlation or autocorrelation of a periodic signal. If xn and yn both are periodic signal, then it is nothing but a normalization factor. Limit n tends to infinite 1 by 2n plus 1, n equal to minus n to n, x of n, y of n minus k, which is defined as Rk. So, this we use in many purpose for find out the periodicity of a signal. Then the properties of autocorrelation and cross correlation sequence. Suppose, forget about this maths, only think, suppose I have a signal A x of n plus b y of n minus l. Now, what is the energy of this signal? This is a total signal. What is the energy? Energy is nothing but a sum and square and sum and square and sum. So, square and infinite sum. Then I said this is A, this is B. So, A plus B the whole square, A square plus B square plus twice AB. So, I can say this is nothing but A square and this is square, that means R x x 0, L equal to 0. This is nothing but a R y y 0 and this is nothing but a R x y L, because L is the shift. So, this is a quadratic equation. If I divided this one by, so I can say A by B the whole square plus R x x 0 plus R y y 0 plus 2A by B R x y L. So, this is a quadratic equation, and let us derive the coefficient. So, I know that I can from here I can find out 4 into R x y square minus R x 0, R x x 0 and R y y 0 must be less than equal to 0. That means I can say R x x x y is less than equal to root over of R x x s and geometric mean. So, any time I can say the correlation coefficient R x x R x y must be less than equal to the energy product or geometric mean of the two energy of the signal. Ex is the energy of the x signal, uy energy of the y signal. When it will be equal? When I said R x y 0, that time it will be equal to Ex multiplied by Ey root. But otherwise it will be less than this. So, if I say instead of x y it is autocorrelation, then I can say R x x must be equal, greater than equal to root over of Ex square, y is replaced by x. So, R x x must be greater less than equal to Ex, energy of the signal. So, when it will be equal? When R x x 0 is equal to Ex, elsewhere it will be less. So, I can say if I compute autocorrelation Rxx, if I compute autocorrelation, let us say I compute autocorrelation, let us say I have a signal x of n, I compute autocorrelation Rxx. Now, if I plot, this axis is the L and this axis is the Rxxl. So, I know at L equal to 0 it will be value will be maximum, elsewhere the value will be dropped down. So, if you see that if the signal is periodic, then you can get this kind of plot. That means the next peak, which is not exactly equal to the initial peak, but the some peak will be happen at the period. So, this to this is called period of the signal. Details I will give you, I will show you the details in here in speech signal. Okay? So, this is the autocorrelation. So, I can use this property of the autocorrelation or correlation property to compute the periodicity of a signal. Okay? So, this is the period. If the signal is periodic, then it will be minus n to n 1 by n. So, I know that the none of the signal, if the signal x of n is exist only exist when the n is greater than equal to 0, then I can say that is 1 by n equal to 0 to n minus 1 k x of n into x of n minus k, that is autocorrelation. So, suppose an application, suppose I told you, can you find out the periodicity of a vocalic speech signal? That means, let us say this is a speech signal collected from human, this is a vowel which is periodic. You can say if you observe the signal, there is a periodicity in the signal. I can say this point to this point is a period, this point to this point is a period, this point to this point is a period. Now, I told you, can I find out the periodicity of the signal using correlation? Yes. If this is my xn and if I compute this is the periodic signal. So, I said take the n number of sample. So, n is greater than n, where n is the length period, n is the period, you know that. Suppose I have a signal, yes, I will come to that practical scenario. Suppose I have told you that I have a signal whose sampling frequency is 10 kilohertz, and let us say the signal has a frequency is 2 kilohertz. So, what is the length of the period? N, what is the value of n? So, within 2 kilohertz, so 10 kilohertz is my sampling frequency. So, signal period is f0 is 2 kilohertz, f0 is equal to 2 kilohertz. So, I can hertz to number, sample number I can easily convert, because I know 10 kilohertz means 10k sample. In 1 second there will be a 10k sample. Then in f0, if the f0 is 2 kilohertz, that means t0 is equal to 1 by f0. 1 by f0 means 1 by 2 kilohertz, that means 0.5 millisecond. So, in 1 second, if there is a 10,000 sample, 0.5 millisecond, how many sample will be there I can find out. Understand or not? So, that number of sample is nothing but a period of that signal. So, I have to find out that period of that signal. So, n. So, let us say I compute this. So, my n, I have taken the signal sample which contain more than one period. Suppose if I take this amount of signal, I cannot find out the period, because it does not contain that at least complete one period. So, that is why I take the n which is much greater than n, maybe 2 to 3 period is at least 2 to 3 period will be there. M will be at least greater than equal to 2 times of at least 2 times of n. If it is there, then if I compute Rxxl. So, this is autocorrelation Rm, that is nothing but a Rxxl. I compute it, autocorrelation, I know Xn, I multiply that things and compute it. And if I plot it against this axis is the L, or I can say here it is M. This axis is M small m and this axis is the value of Rxx. Let us say this is called L. So, this axis is L and this axis is Rxxl. Then you get this kind of plot. If you see, it is going decayed down. Now, I can say the maximum peak, next peak can happen when it is a period. So, I can say this to this length, this much of L is the period. So, if I know that L, if I detect this peak and find out the index, let us the index is come 40, let us say. So, if this signal is sampled at 10 kilohertz and I get the next peak at 40. So, what it means? This 40 is the periodicity. So, I can say I can easily convert it into the hertz frequency, because this is time, n is equal to 40, that can be converted into T0. Once I get T0, 1 by T0 is equal to F0. I get the fundamental frequency. So, I take the signal, compute the autocorrelation and find out the next peak. So, that peak give me the period. Understand? Now, the problem is the amplitude is decaying. If I want to make the amplitude constant, so this is F0, so this is twice F0, so that is why 2 T0, this is thrice F0. So, now if I want to make that amplitude is constant, that is called normalization. So, which is called normalized cross correlation or normalized autocorrelation. How do you do the normalization? Forget about the theory, what is written in here. So, how do you do the normalization? So, I compute Rxxl. So, I know Rxx0 is equal to E0. So, if it is autocorrelation, I can say normalized autocorrelation coefficient, let us say PL is equal to Rxxl divided by E0. If it is cross correlation XY signal, so Rxyl divided by root over of Ex into Ey, geometric mean of the two energy of the two signals. So, that is normalized cross correlation and this is normalized autocorrelation. Understand? So, that way we can calculate the normalized cross correlation and autocorrelation. Once you normalize it, then if you see, this is my signal, this is my autocorrelation without normalization, amplitude is decaying. Now, if I normalize it, then if I plot it, if you see, the amplitude is not decaying. So, this is the F0, this is twice F0, this is thrice F0. So, this is the requirement for correlation and this is the procedure to compute correlation. Is okay? That slide you can say what is the difference, suppose somebody asks you what is the difference between the convolution and correlation. So, convolution is the relationship between a system input signal and output signal and impulse response. I know the output signal is a convolution of the input signal and impulse response. Correlation is a way to detect a known waveform in a noisy background. Correlation, only operation we do not perform, that is the folding. In convolution, we fold it and then shift it. Here, without folding, we just, there is a one signal and there is another signal, either we slice this one or we slide this one. This is the difference between the correlation and convolution. Okay? Thank you.